Hello everyone, today's meeting about production process control. Let's begin. So, what is production and process control? The goal of every quality management system, especially as regulated as medical device, is to produce products that are fit their intended use. Production process control is one of the components of core processes that build quality management system. That the goal of those core processes is to make sure that the principles and goals of the quality system are met. And we as a manufacturer need to develop, conduct, control, and monitor production processes to ensure that a device we build conforms to its predefined specifications that were identified during design and development stage. So what are production process control? And what processes build this control, these production processes? So first of all, people. All people involved in production need to be properly trained. It doesn't matter how good our processes, it doesn't matter how good our quality assurance, it doesn't matter how good the equipment we use. If people do not know what to do and how to produce a quality product, that's bad. And how we make sure that those people know exactly what to do and train what to do. They need to be able to identify defects that can or might or visible or invisible during the device production, during the labeling, during the packaging, during the installation procedures. Those people need to identify those. And those training records should be recorded. Additional component of production control processes is the sufficient space. We need to have sufficient space to hold, to handle, to process our equipment, our components, our in-process devices, our accessories, our finished devices. So there is no problem with the space. We should have identified space for all those parts. In addition, we need to have sufficient space for production process itself, for manufacturing process. And this done, the facility or building control is done to avoid contamination. The major reason is to avoid contamination, meaning the raw materials we received from suppliers are not in our supply room before it's quarantined and tested. The stockroom, I mean. The rejected materials are separated, and the production areas that we actually do our assemblies are cleared from previous unit information. No packaging, no labeling, nothing. This space is supposed to be clean and prepared for specific production unit assembly. We need to make sure that we maintain our equipment. This equipment should be adjusted, should be clean, should be in place and ready for production. All the equipment we use for production should be, all the measuring equipment we use for production should be calibrated. And during the production time, we need to make sure that the calibration date is up to date. we need to control labeling. So it's not only the label itself, it's the labeling process. So we need to make sure that all the labels remain in place, legible during all the stages of distribution, storage, and use. All the user manuals, if we provide those in physical manner, are final version and remain legible during use and storage of the customer. And finally, we need to make sure that all those labels or labeling materials are inspected for accuracy before the release. The packaging is supposed to follow recommended carrier instructions, unless special packaging is required. That's according to our procedure. So, special packaging recommendation procedure for special packaging determined by responsible manager, project manager, or designated of this project manager. And all this packaging supposed to be packaging instructions supposed to be recorded and approved. Before we start with production, we need to have in place several documents. We need to have finalized BOM. We need to have approved materials acceptance specifications, and we need to have testing procedures. Unless some of the materials can affect product quality, we need to have procedure that will describe the removal or use of the specific material. All this is supposed to be in place before the production starts. How do we monitor and control the production process? One of the main assumptions during the product design phase is the production process will be stable and we will be able to replicate our products. And it's done by testing and inspection. That's obvious. So some of the processes cannot be fully verified. Then those processes are supposed to be validated. And one of the examples for processes that need to be validated is the use of software programs in production process. So we have, for example, Helix. We have, for example, we will have NetSuite that are going to be validated, but it's different story and we will discuss it in different training. Production processes include installation, operation, and performance processes. And we have process validation and verification plan that describes all those processes for each of our products. So, what kind of processes cannot be fully verified? Those processes when the outcome is not single, there are variations to those outcomes during the production stages or during use of finished devices. And the example for this process, as I mentioned here, is injection molding, 3D printing, software interfaces. All those processes cannot be fully verified, and we need additional validation for these processes. So, how we monitor and control the production processes here in Bell? So, we need to identify the production processes, and it's done by manufacturing process flowchart assembling, and I don't know why it's here, but process validation and verification plan. So we identify all those processes that build our product. Then we start verification process. The verification process is established through process validation verification, is recorded in process validation verification record. When we establish all the steps for specific process, we test each of the steps. An additional tester supposed to make sure that those steps are fully repeatable. And then, in case there is the deviation occurs, the steps needs to be, the verification report should be adjusted and recorded in our quality management system. As a result of this verification process is finalization of the work instructions. So we know this process works. Several testers checked this process. Now we can finalize the work instruction. This work instruction needs to be approved prior to our production. During the production, for each of those processes, we have manufacturing process record to follow. The manufacturing process record is an acceptance of those production unit conform to the work instruction. Each of the process that we do during production done in accordance to those work instructions that were accepted and verified. So this is example of manufacturing process flowchart for a geodesic head web. So we have identified processes. For each of those processes, we have verification record that conform that these processes are the processes needed to be done and can produce stable results. As a result, we produce work instructions that we need to follow to accomplish this specific process. And during the production of the specific unit, manufacturing process records are filled to validate that this process is actually as it's supposed to be. Those MPRs are the acceptance records, that what we received during the production is what we expected to receive during the identifications of the processes. Those records that I mentioned, there are a lot of records during the production stage. So we have manufacturing process records, we have work instructions, we have labels, we have labeling, like user manuals, we have process verification and validation records. In case something occurred and we found defects, we have non-conformance investigation records, we have training records, we have all the logs for equipment maintenance and calibration. So there are a lot of things and everything needs to be recorded, because as FDA claims, if it wasn't recorded, it didn't happen. Sorry about that. So let me remind you what is the difference between DHF, DMR, and DHR. So there is an error here. It's supposed to be can I write? Device. Okay. So the records of the design and development of the medical device build the design history file. That's the repository of all the history of design, development, verification, and validation activities. In addition to risk management activities, usability activities, etc. So that's the whole history of how we developed this device. Later on, some of those records build the device master record. I don't know why it disappeared again. The device master record is the actual recipe. How to make this device. It includes all the procedures, all the instructions, all the finalized BOM for this specific device, quality assurance processes, checklists. So all these documents build our device master record. They provide the production team the instructions of how to make the device. The actual production records for the specific device, for the specific production unit, we call it design history record. It's the confirmation of how this recipe turned out. So I mentioned the design history record is the repository of confirmation of the production records. So it includes all the manufacturing process records, and it includes several more documents. One of those, we call it design history record form. This form contains several sections. It records the date of the manufacture, the quantity that was manufactured, the quantity released for distribution. In a lot of cases, it's the same. And it includes the control numbers used, identifications number used, part number and serial number. In addition, it includes the list of manufacturing process records and other materials, other records that specific for this production unit, as label for this specific unit, etc. So let's summarize. As I mentioned, production and process control is one of the key processes that build our quality management system. That's the process that confirms that our device was built in accordance to defined specifications. The purpose of this process is to ensure that we actually plan, execute, monitor, and control. Product control repository shall include drawings, specifications, work instructions, labeling, packaging, and inspection procedures. The design history record contains only production records that specific to this particular device we built. Thank you and see you soon.